Question 8. 2 lines. It says show that they do not intersect. Okay, so you can actually see that these lines, you can see almost very easily that they're parallel, because this direction vector is 2, -2, 2. This direction vector is 1, -1, 1, which is there. This is a multiple of this. So you could actually say that they're parallel, and you just need to show then that they're not the same line, because if they're the same line, then technically they kind of do intersect everywhere. So you could just show, all you need to do is show that 3, 2, 1 or 3, 2, -1 is not on this line, or 2, 0, 4 is not on this line. That's probably actually the easiest way to do it. The way I'm going to do it is just the kind of more normal way, just to show you if you didn't, because that's less common that you would see straight away that they're parallel. Like you mightn't know, they mightn't be parallel at all, and they wouldn't intersect. So if they intersect, then all these these equations must be satisfied. So 3 plus 2 lambda has to equal 2 plus mu, because basically the x-coordinate of this is equal to 3. This is 3 plus 2 lambda. The y-coordinate is 2 minus 2 lambda. The z-coordinate is -1 plus 2 lambda. So this is just another way of writing the same thing. X-coordinate, y-coordinate, z-coordinate. They have to equal the x-coordinate, 2 plus mu, 0 minus mu, which is just minus mu, and 4 plus mu. These have to, the x's have to equal, the y's have to equal, and the z's have to equal. So this has to, they have to equal, this has to equal 2 minus 2 lambda equals negative mu. And finally, -1 plus 2 lambda equals 4 plus mu. So let's call this 1, 2, and 3. Now you're just going to have to solve these. I'll just solve the first two and then sub into the final one to see if it is satisfied, which no doubt it won't be, because it's saying they don't intersect. So the first two, solve 1 and 2. So solve these two together. You could well, actually, if you added the two equations, what happens is they well, actually, yeah, I'll try to solve for 1 and 2, and you'll see straight away that this won't work. So 3 plus 2 lambda equals 2 plus mu, and then 2 minus 2 lambda equals minus mu. So if I was to, I'm gonna add these two equations as you would to eliminate the mu's or the lambdas or the mu's, but when I add them, the lambdas and the mu's are actually going to disappear. So I'm going to have 5 plus 0 equals 2 plus 0, which obviously 5 equals 2. I'm going to say, but 5 is not equal to 2, therefore they don't intersect. And that's enough, because if I can't even satisfy these two equations, there's no lambda and mu that satisfies these two equations, then they don't intersect. If you didn't have a situation where these cancel out nicely, you just find the mu and lambda that satisfies. Usually you can find a mu or lambda that satisfies these two equations. You can't in this example because they're parallel. And then you just sub that mu and lambda into the third equation, and that won't be equal. You'll get a situation like this. Anyway, that's part A. Part B. Find the minimum distance between L1 and L2. Right, in these examples, guys, I like to draw my lines. So I'm going to draw 2 lines. They don't have to be well, these are parallel, but you don't have to obviously draw parallel lines. So I am going to draw parallel lines. Let me give it a bit more space, like this. So let's say this is L1. Let's say this is L2. Okay, the key to the distance between two lines is to find the perpendicular distance. This is the perpendicular distance. And, well, I just need a point on either of these lines. So I know, let's go with this line here, or this point, 2, 0, 4. So this here, let's say this is on L2, 2, 0, 4. So the point is 2, 0, 4. I am going to call it the position vector 2, 0, 4, because that's going to help me in a second. Now this point here, it's not 3, 2, negative 1. Don't make that mistake. 3, 2, negative 1 could be, I mean, it actually might be, but it's very unlikely that that's the point that's right perpendicular to this point. So the point that's here, that I definitely know what it is this general point, because this is every point on the line is this 3 plus 2 lambda, 2 minus 2 lambda, and minus 1 plus 2 lambda. Like this. Okay, so to find this vector, well, hang on, I want to find lambda. I want to find this point first. What I know is that this vector here has to be perpendicular to the direction vector of this, or even this one here. So the direction vector of, well, again, let's actually pick L2. The direction vector of L2, hang on, let's choose a different color. The direction vector of L2, this direction vector, is actually 1, negative 1, 1. So I know that this vector and this vector are perpendicular. Now let's say this vector here. Now this vector here, let's actually call these points, guys. This is going to help us out. I'm going to say this is point A. Let's call this point A, and we'll call this point B. So I'm going to say that, well, AB, the point AB is equal to A minus B, or the vector AB is equal to B minus A, the position vectors, this minus this. So hopefully, guys, you are all okay with this, what I'm about to do. It's 3 plus 2 lambda, 2 minus 2 lambda, minus 1 plus 2 lambda, this minus this, so this minus 2, 0, 4. And this equals 3 minus 2 is just going to be, that's 1, so it's 1 plus 2 lambda. Minus 0 is obviously nothing, minus 2 lambda, 2 minus 2 lambda. And then minus 1 minus 4, that's actually going to give me minus 5 plus 2 lambda. So this vector here, this vector is AB, and AB is perpendicular to this vector here. Let's call this vector D for the direction vector. So I can say AB dot D is equal to 0, because perpendicular vectors, the dot product equals 0. What's AB? AB is 1 plus 2 lambda. Yes, guys, this is a difficult question. 2 minus 2 lambda, and minus 5 plus 2 lambda. So this dot product of 1 minus 1, 1 equals 0. All right, let's move down a bit. I am going to multiply these out. So this times 1 plus 2 lambda, plus this times minus 1, which is going to be minus 2 plus 2 lambda, be careful, plus minus 5 plus 2 lambda. So it's this times this plus this times this plus this times this equals 0. 1 plus 2 lambda. So hang on, I have 1 minus 2 minus 5 is negative 6. That is negative 6. And I have 2 lambda plus 2 lambda. Hang on, am I right? That is, oh yeah, it is 2 lambda. Yeah, sorry, that was minus 2 plus 2 lambda. So it's 2 lambda plus 2 lambda plus 2 lambda is 6 lambda equals 0. 6 lambda equals 6. Lambda equals 1. Okay, what were we even trying to find? We're trying to find the distance between L1 and L2. So we're actually trying to find the distance of AB. Okay, so AB, I'm going to say therefore AB is equal to, I'm going to sub 1 in here for lambda. So it's going to be 1 plus 2, 2 minus 2, and minus 5 plus 2. Do that again. This, and it's going to be 3, 0, negative 3. This is AB, so this is this vector. All I need to find is the length of this vector now, and the length of AB, or the magnitude of AB, is equal to the square root of 3 squared plus 0 squared plus negative 3 squared, which is the same as plus 3 squared, equals 9 plus 9 root 18. So it's, hang on, it is the square root of 9 plus 9, which is 18, or root 9 times root 2, which is 3 root 2. That's the minimum distance. So obviously that's not straightforward. There's a few different ways that the mark scheme show it, a few different methods from the mark scheme. That's the method that I kind of have always stuck with, and it's the method that makes the most sense, and I think it kind of then applies to, or is useful in other situations that are asking for a similar kind of asking a similar kind of question. So that's the one I stick with. But of course, check out the other methods and see if they make sense. Okay, that's question 8. I'll see you for question 9.